Ready-made maths YouTube training videos. Teacher and teaching assistant training. Today we're at day 8 of our repertoire of mental multiplication strategies. The previous couple of sessions we've been looking at strategies associated with doubling. We first of all looked at specific doubling on strategies, and then in the previous session we looked at manipulate the calculation, which looks at doubling and halving, multiplying by 3 and dividing by 3, and so on. Today's strategy, though, is quite a simple, short strategy that looks very specifically at multiplying by given numbers and then halving them. These are usually multiplying by 10, 100, and 1,000. Those are numbers that are very, very easy to multiply by, and they're also relatively easy to halve. And a little bit like with manipulate the calculation, they will enable you to make a complex calculation far easier to solve. Just to quickly recap, over the past 7 days, we've introduced all of the strategies. Then we've had 1 day on manipulate the calculation in the previous session. We've looked at doubling strategies in the session before that. We've looked at rounding and adjusting. We've looked at reordering. We've looked at factorizing, and we've looked at partitioning. We've looked at pretty much all of the main strategies that children can learn and be taught regularly, so they have a nice bank of strategies. So whenever they see a multiplication, they're able to look at it and think, right, can I do this in my head? And if so, what's the best strategy that I can use? We've kind of covered the first 8, and so we're now onto the 9th strategy, which is multiplying by something, usually 10, 100, or 1,000, and then halving. And in the final session tomorrow, we're going to move on to the final strategy, which is jump. So what we're going to do now is move over to the ready-made maths classroom, where I'll be able to demonstrate how this strategy works.
Hello and welcome to the Ready-Made Maths YouTube channel. What we're going to be looking at today is almost the last of our multiplication strategies. We're going to be looking at multiplying by something and then halving. It's kind of a continuation of the doubling and the manipulating the calculation strategies that we've looked at in the past 2 videos. It only works with certain numbers, does this strategy, but it's certainly worth looking out for, because sometimes you'll see a calculation where you need to multiply by, let's say, 5 or 50 or 500, and straight away there's an easier way of doing it. We can multiply by 10 or 100 or 1,000 and then half. So what I'm going to do today is I'm going to look at 3 relatively easy calculations, or ones that we can use previous strategies for. And I'm going to look at a similar version of those, but ones that are slightly harder. Then I'm going to show you some visual resources that back up what we've been talking about. And then finally, we're going to look at some slightly more complex calculations towards the end. So as I say, this particular strategy of multiplying by something and halving, you've got to find the particular numbers that it works for and keep your eyes open for them when they appear. So let's begin. 5 multiplied by 8. Now I'm hoping everybody who's watching the video knows that one as an instant fact. 5 times 8, 40. But let's imagine we didn't know 5 times 8. Do we know another calculation in the 8 times table that's even easier? Well, I think apart from 1 times 8, I think the first fact that children learn is multiplying a number by 10. So we start off with 10 times 8. 10 times 8 is 80. And if we halve that, we then get the answer of 40. So actually, multiplying by 5 is exactly the same as multiplying by 10 and halving. In a similar way, multiplying by 50 is exactly the same as multiplying by 100 and halving. So what's 50 multiplied by 14? I'm not sure. What's 100 multiplied by 14? Well, 100 times 14 is 1,400. 50 will be half of that, and that will give us the answer, 700. The final example, 500 multiplied by 12. Again, we could probably work that out anyway, because we probably know that 12 fives are 60 and work it out from there. But if we actually think about it as an even easier strategy, well, what's 1,000 times 12? 1,000 times 12 is 12,000, and if we have that, that's going to give us 500 times 12, which must be 6,000. Now, the reason I've kind of started with those is actually, if we'd have used last time's strategy of manipulate the calculation, we could have just double and halved. So if I rewrite underneath, well, double 50 is 100, and a half of 14 is 7. That's even quicker. Double 5 is 10, and a half of 8 is 4. Or double 500 is 1,000, and a half of 12 is 6. So you might well have said, well, we could have just used the previous strategy, that would have made it equally as easy. And in those instances, it would have done. But the other strategy does work as well. So we can either double and half like we did yesterday in the previous video, or we can use this idea of multiplying by the 10, the 100, the 1000, and then halving the answer. But the reason I started with those and then made them a little bit smaller is actually these ones don't work in the same way with double and half. Well, what would that one give us? 5, that will give us 10 times 3.5. It's not difficult, but it's certainly got a decimal in there. This one will give us 100 times 6.5, and this one will give us 1000 times 5.5. And a lot of children are not happy with decimals when they first, introduced to those calculations. So I think using the idea of multiplying by 10 or 100 or 1000 and then adjusting will probably make those calculations a little bit easier. So let's have a look. Let's just remove those out of the way. And let's have a look what we could do using this as a mental strategy. 5 multiplied by 7, I know we know the answer is 35, but let's just try the strategy. 5 times 7, well 10 times 7. 10 times 7 equals 70, therefore 5 times 7 is half of that, or 35. 50 times 13, well let's work out 100 times 13. 100 times 13, so that's 1000. 100 times 13 is 1300, and again, half of that is 650. So we could 50 times 13, not a lot of space on the board, but it's 650. And the final one, 500 multiplied by 11. Well, what's 1000 multiplied by 11? 1000 multiplied by 11, I'll just write that here. 1000 multiplied by 11 equals 11,000. And a half of 11,000 is 5,500. So what this is giving us is an alternative strategy. When we see a number that is a 50 or a 500, we can make it much easier by multiplying by double that and then halving the answer. So what we're going to see now is we're going to move over to the table. I'm just going to show you some examples just to prove visually how easy it is to multiply by 5. Don't multiply by 5, multiply by 10 and half it. Don't multiply by 50, multiply by 100 and half it. So we're just going to see a couple of examples as a visual, and then we're going to apply that strategy to those numbers over here. So here's just a quick visual. If you do want to explain to children visually and in order to master the calculation why this actually works. What you can see here, you can see 10, 20, 30, 40, 50, 60, or 10 multiplied by 6. I've got 10 repeated 6 times. I've got 10 multiplied by 6. 10, 20, 30, 40, 50, 60. What I've actually got above, and I think we can see straight away, what I've got above this 10 is half of it, 5. Above this 10 is half of it again. Above each of the 10s, I've got a 5. So I can clearly see straight away that what I've got above each of the 10s is half of what's in those boxes. So what I've now got is not 10 multiplied by 6, but 5 multiplied by 6. Let's count those. 5, 10, 15, 20, 25, 30. We've got 60 here, which is 10 times 6. If we half the amount in each box, as we've talked about, it's the opposite of what we did with the doubling. We half the amount in each box, therefore the product is a half of what we started with. 10 times 6 is 60, and 5 times 6 is 30. And what's quite nice is just by passing some of the cubes over, we can actually quite quickly prove that it is exactly a half. I'm going to move that one out of the way, put that over there, drop those in here, and that gives us 20. And again, drop this over here. So that's two ways of proving a half. We can prove a half in each box, and we can actually prove a half of the total amount. We can see 60 there, and we can see 30 here. So 5 times 6 is 30. Now I know we know those answers anyway, but that's just a simple little proof to show children how it works. Now what we're going to do now is move shortly to another part of the table, and we're going to look at a much bigger calculation. Okay, now looking at the base 10, what we can now see are groups of 50. So we've got 50 multiplied by something. Well, let's have a look how many we've got. We've got 50, and I've set them out 5 style so you can see it straight away. I've got 50 times 5, 50 times 10, 50 times 13. I've got 13 50s, 50 multiplied by 13. Now, obviously I can see the answer by looking at this. If I want to put them together, I could. But just leave it at the moment as 50 multiplied by 13. We don't know the answer yet, but that's what we can see. If we then look above, what we can then see is exactly the same picture but set out in hundreds. So I've now got 100 multiplied by 5, multiplied by 10, whoops, sorry. I've got 100 multiplied by 5, multiplied by 10, multiplied by 13. So I've now got 100 multiplied by 13. Well, I can see what that answer is straight away. I can see 1,300. 10 hundreds make 1,000, and I can see that that's 1,300. So what I can hopefully prove is that what's below is half of what I've got here. This is 13 hundreds. What's a half of 1,300? Well, a half of 1,000 is 500, and a half of 300 is 150. So if I just jot down, if I was to put my half of 1,000 there, so a half of 1,000 would be 500. I can actually see that's the 500, and a half of this 300 will be 150. And what that should give me is 650. Let's have a look down at the reds again, and let's put them together. Have we actually got, we can definitely see we've got half of the amount each time, and I can just prove that by looking. Each of those 50s is half of one of the hundreds. So let's prove that our product is also a half. So 50, 100, 150, 200, 250, 300, oops, 350, 400, 450, 500, so I've got 500s there, 550, 600, and another 50. 1, 2, 3, 4, 5, 500, 650. So what we've actually proved is that 50 multiplied by 13 is exactly the same as 100 multiplied by 13, but then half the answer. Now, once we've proved that a couple of times, again, we've done the proof now, it then just becomes a mental strategy for year 5 and 6 that they employ all the time. How do I multiply by 50? Well, I multiply by 100 and just have the answer.
So just to reinforce what we've seen in the classroom, in the previous training video, we looked at the idea of if you double one number in a multiplication calculation, 6 times 4 equals 24, then what's going to happen if we double the 6 or double the 4, then the products will double. We looked at that in the previous session. So we can go from 6 times 4 to 12 times 4, or from 6 times 4 to 6 times 8. Whichever way we look at it, one of the numbers is doubled, therefore the product has doubled altogether. What we've also looked at, though, is if you start with a multiplication fact and halve one of the numbers, 6 times 4 equals 24, will give us 3 times 4 is 12, or 6 times 2, that is 12, whether we halve the 6 or we halve the 4. And that's the principle we've been applying today. What we've been doing, though, is applying it to the number 10. If for example, this was 6 times 10 equals 60, we could then halve that 10 to make it 6 times 5 equals 30. One of the examples that we looked at back in the classroom. And if we constantly use that strategy and practice it in class, it's something that children will just start to use naturally.
What we're going to do now is take that idea of multiplying by 10 or 100 or 1,000 and halving and just take it one stage further. What happens if we've got to multiply by 2.5, 25 or 250? Again, it's the same principle, but this time we find a quarter. What we should hopefully know is that 2.5 is a quarter of 10. And if we don't know that, obviously make sure the children have got that one as a secure fact. 25 is a quarter of 100, 250 is a quarter of 1,000. So if you're asked to multiply by 2.5, now yesterday we did look at the doubling and halving trick, but really that's going to give us, if it was 46 times 25, that's going to give us 23 times 5, or then we've got to halve 23, and it's just becoming a little bit too complicated. So what we're going to do with this one is we're going to, this time, multiply by 10. So 46 multiplied by 10. Very, very simple, 460. 46, therefore, multiplied by 5. As we know, we've just proved it, is half of that, 230. So 46 times 2.5 must be 115. We've cut out the need for any decimals over here. We've just got rid of the decimal completely. We've just made it 460, 230, 115. If a child is taught that strategy and practices it regularly enough, they'll look at it and go, oh, brilliant, times by 10, and half it twice. And we get the answer really quickly. Similarly, with 82 times 25, we could do a double and half, and that will work with some numbers, But with this one, that will give us 41 times 50, and then they've got 20 and a half. I mean, I can write it down. We can write 41 times 50, or 20.5 times 100. And again, if you're good at decimals, that's great. You'll get there using manipulate the calculation. But what I want to do now is just look at, for this particular set of numbers, a slightly easier way. 82 multiplied by 100. Straightforward. 82 multiplied by 100, 8,200. 82 multiplied by 50, therefore must be, 82 times 50 must be 4,100. And then all I do to do 82 times 25 is halve the 4,000, 2,000, half the 100, which is 50. 2,050, which is obviously the same as 20.5 times 100. But this way definitely is much, much quicker. We just need to know our halves of numbers. All we really need to know is half of those, but it's, you know, a much, much easier one to do. That brings us to the final example on the board, 56 times 250. Let's straight away do 56 times 1,000. We don't need to be particularly good at maths to do that one. 56,000. So 56 multiplied by 500 must be half of that. You only need to know half of 56 here, which is 28,000, or half of 50 and half of 6, and put them together. Therefore, 56 times 250 must be a half of this, must be 14,000. Like I've said on many other videos, just look at the difference between long multiplication, 250 multiplied by 56, where we'd have to be doing all sorts of exchanging and remembering the rules and conventions and so on, or, oh brilliant, it's 250, 56,000, 28,000, 14,000, done. They are greater depth strategies, but they are ones that are really worth teaching so that children have got a repertoire. Like we said, double and halving, as we did yesterday, fantastic for many calculations, but when they're these particular numbers, you've got another way that's often even easier.
Let's just have a quick look at the visual calculation policy from senseofnumber.co.uk. As you've probably seen in some of the other videos, I use this policy to kind of exemplify all the different strategies that we've been looking at. We can see here 86 multiplied by 5, very simple, 86 times 10, 860 and half it. It can be done in a fraction of a second, as long as we recognise multiplying by 5. Oh, we'll use that strategy, we'll multiply by 10 and half it. Similarly, 56 times 25, we looked at that one back in the ready-made maths classroom. Well, what do? Well, we do 56 multiplied by 100, 5,600, and just half it twice, 2,800 and 1,400. As I've mentioned, if you want to have a look at this and get a hold of it, do go to senseofnumber.co.uk. There's something around about 550, 560 posters showing concrete pictorial, mental and written methods that will give you all the things that you need for a working wall. You can have your own bespoke policy created, including all the strategies you've seen in all the different videos from place value and mental calculation. So do, if you get the chance, have a look at the Sense of Number website and have a look at any of these particular A3 or A4 posters.
And just a final example that proves actually it doesn't always need to be multiplied by 10, 100 or 1,000. As long as we know that if we've got a decimal, we can multiply by double that decimal and then halve it to get the answer. 9 times 1.5. Again, if we tried the manipulate the calculation trick from the previous video, we'd double and half and end up with 4.5 multiplied by 3, which is, you know, not really any difference. But what we can do is think, wait a minute, let's just do 9 multiplied by 3. Fantastic. 9 times 3 equals 27. Half of that, so 9 times 1.5, half of 27, well, half of 20 is 10, and the half of 7 is 3.5. And we end up with 13.5, so it can still be used as a decimal activity as well. So it is a strategy, certainly for 25, 50 and so on, well worth remembering in 5. And it's one that we then eventually start to use just regularly. I've just got here a random set of digit cards. Whatever I turn over now, I'm going to multiply by 5. 63. 63 times 10, 630. Half of it, 315. Straight away, just multiply by 10, half it. Multiply that by 5, we can do that in our head. 6 times 5 is 30. 23 times 5, 230, 115. Don't bother with 50, we know that one. 42 times 5, 420, 210. 72 times 5, 720, 360. So you can see each time I'm just multiplying by 10 and halving it. It's a lovely little game to play with children as well. How quickly can they do it? Just turning cards over. 8 times 5 is 40, 42, 420, 210. 20 times 5 is 100. 53 times 5, 530. Half of 500 is 250. Half of 30 is 15. So we end up with 265. So just keep practicing it, build it up as a jotting until it's something the children are just doing naturally. They're multiplying by 10 and halving. Thank you very much for joining me for today's video. We've only got one more multiplication strategy to look at, which is the jump strategy, which is more for kind of decimal numbers, for multiplying by 10 and dividing by 10, 100 and 1,000. That's why we didn't really look at that one today when we had the numbers over there. So got one more strategy to do, which is going to be just a short video looking at that idea of how do we very quickly multiply decimals by 10, 100 and 1,000, and how do we divide decimals by 10, 100 and 1,000. What's the key strategy? What we've looked at today though is multiplying by 5, 50, 500, 2.5, 25, 250 by using a really easy fact, the 10 times, the 100 times and the 1,000 times. So I hope that's a strategy that you found helpful, and if we put that alongside the doubling strategies that we did 2 sessions ago and the kind of the double and halving strategy, the manipulate the calculation that we looked at in the previous video, what we've now got are kind of 3 or 4 really good strategies that are all involved with doubling and halving. And if we teach them lots, and we build them up in year 4, 5 and 6 as something for children to always look for, then that's what they'll start to do. If we teach them as a one-off calculation, teach it as a little mini strategy in a lesson, they'll go, oh, that's nice, and then it's gone. But it's part of our regular repertoire, and we constantly build it up in mental calculation. It will be something that children will do naturally, that they wouldn't have done previously. And possibly even more importantly, it's something that you yourselves will start to do naturally. You'll see a 25, you'll use that idea that it's a quarter of 100. You'll see a 2.5, it's a quarter of 10. So as I say, thanks so much for joining me, and please join me tomorrow for the final multiplication strategy video.
That's it for today. We've just got one little strategy left, completely different to all the others. This is a strategy that just helps children see the idea of multiplying or dividing actually between 10, 100 and 1,000, especially when we start to move into decimals. So I can see you tomorrow, and we're going to have a look at a little strategy called jump. And to do that, we're going to be using a mathematical song and also a mathematical kind of ICT resource that was created by the National Numeracy Strategy. So if you're interested in that, having a quick look at that tomorrow. It'll only be a short video, but I look forward to seeing you there for a little bit of singing and a little bit of ICT. Thanks a lot, and I'll see you all tomorrow.